Okay, so today here we are looking at sample mean. Alright, so we're now moving on to sampling, and we're looking at sample means of a normal random variable. So sometimes if we've got a massive population, it's difficult for us to survey that whole population and then get the information and work out the mean. So what we'll do is we do a sample of the population. Alright, so when a sample rather than the whole population, we put this bar on top, as you can indicate we're using a sample. Alright, and these next things, your textbook has an explanation of these things, these ones here. So for a sample, the expectation value of our sample is considered to be the same as the expectation value of the whole population, which is mu, and the variance of our sample is the standard deviation squared over n, and n is our sample size. So this standard deviation would be our population standard deviation, and then over n. And so the standard deviation of our sample then is the square root of that, of course, which then is just sigma over the square root of n. Alright, so as I said, there's a detailed explanation of that in your textbook on those pages if you are interested. Otherwise, all we have to do is we have to be able to use these things. Alright, so let's have a look at an example. Right, example 10, we're not doing example 10, but it's got the information we need for example 11. So experience has shown that the heights of a certain population of women can be assumed to be normally distributed with a mean of 170 and a standard deviation of 8. All right, so this information that again it says is it's a certain population. Word population is the key there. And so this mean and this standard deviation, they're the population. Okay, so consider the population described up here. What is the probability that a woman chosen at random has a height greater than 168? All right, so in this, before I get to part B, we won't read part B because that starts to confuse the issue. If we look at part B, what we've done is consider that population. What's the probability of a woman chosen from that population is the height. So you've got to be clear that you are looking at the population or a sample. Which one are we interested in? So A here says a woman chosen at random, and we've just immediately prior to that read about the population. Whereas C and B, it says a sample. All right. So you've got to be careful about what you use. So if the part A, our mean, is 160 and our standard deviation is 8, and so we just use those figures, and we are after the probability that a woman chosen at random from that population is greater than 168 centimetres tall. All right, so that of course is for this particular this particular population with this mean and this standard deviation. And so don't forget that conversion factor back to Z is x minus the mean over the standard deviation. So if this is our x value, our Z value that we're looking at would be 168 minus the mean, which is 160, over 8, which of course would be 8 over 8, which is equal to 1. So what we are interested then is in, for that probability, we're interested in the probability that x is greater than, not x, that z is greater than 1. All right, so now that's where we go to our calculator. So here's our calculator. We go to our calculator. All right, we go to our menu. We can go to statistics. Remember, we're calculating something. We're calculating something from our distribution. And it's the normal CDF distribution that we're looking at. Next, our lower limit. All right, we were greater than 1, wasn't it? Greater than 1. Upper limit, remember, it doesn't matter unless we've given 1. If we're going up forever, like we are on this one, we just use a large number. So there's our large number, our mean and our standard deviation, because we're using Z. 1 and 0. Go next. And there's our probability, 0.1587 by the looks. So that is 0.1587 probability that a woman chosen at random from that population would be greater than 168 centimetres tall. All right. Now, part B tells about the sample. So now we've got to make adjustments to our mean and our standard deviation. So B is now we're talking about a sample. And the sample is size 4 out of our population. All right, so back up to this stuff here. So the mean is the same for each, all right? So our mean is the expectation value of our sample is the same as that of our population. And so that is 160. The variance, however, of our population is related to the standard deviation over n. And so that standard deviation, of course, is the standard deviation of our population, which we were told, I think, was 8. Yes, 8. So we've got 8 squared over n, which is 4. So we got 64 on 4, which when you work that out, that comes to 16. Now we're after the standard deviation of our sample. And so that is the square root of the variance of our sample. So that is 4. So what were we after? We're after that the probability in our sample is greater than 168. So we're after the probability that someone in our sample is greater than 168. Now we're going to use, of course, our go to Z, and remember using that same conversion factor we did here. All right, but this time what we want to use is we want to use our sample statistics, so our sample U and our sample standard deviation. All right, so I could write, if I modify that, I'd say that Z of my sample is equal to X of my sample minus the mean of the sample over the standard deviation of the sample. All right, so we're looking for the probability then that Z for the sample is greater than 168 minus the mean of the sample. Sorry, wrong, 16. Looking at the wrong place. There it is, mean. mean of the sample, 160. Over, now here's where I want standard deviation of our sample, which is 4. All right, so the Z for our sample that we're looking at is greater than 8 divided by 2 then, isn't it? All right, and so we now go back to our calculator. We go here. So let's go back. I'm already in it, so go back, normal CDF, yes. Our lower limit this time is 2, and our upper is 999. See, I only had to just change the one thing there. So next, and so there it is. There's our population. The probability that a person selected at random, not at random from the population, but a person from our sample is greater than 168 centimetres is 0.0228. 0.0228. All right, and so that is probability that a sample of 4 women chosen at random has an average height greater than 168. So those 4 women, when we work out what their average height is, what's the probability that that average height is greater than, of those 4 women, it's greater than 168, and there it is here. All right, and that is basically what we're looking at here in terms of the sample mean of a normal random variable. And so later on we're going to do more about this, about the sample mean. As I said, sometimes it's hard to survey the whole population. So when we do that, it's called a census. And so we don't do censuses all the time, because if you're going to do with a big population, so like the population of Australia, 20 plus million, that's a lot of information, and so it's not practical to be able to gather that amount of information and then analyse that information on a shorter time scale. All right, so i.e. like on a week-to-week basis of things. All right, so any questions about that, make sure you ask, and as always, have fun.